Hello and welcome to another episode of Math with Sohn. Today we're going to be talking about two tangents that intersect and what happens when a tangent and a secant intersect with a circle. So if we have a circle, and instead of it being a secant, which is this guy, and another secant, like another one with it, we're going to have a tangent line intersecting with it, which means it's going to go from the side of the circle and then intersect right there as well. So instead of it going through the circle, it's going through the side of the circle. And when you have a problem like this, if you are looking for the angle, then it will be the same as if we had two intersecting secants. So it's still going to be this big arc right here. Let's say that's 120. And let's say that's 50. So if we have those two things, it is still going to be the big arc minus the small arc is equal to 2 times the angle. So nothing changes there. So we end up with 120 minus 50 equals 2 times the angle. So 120 minus 50 is 70 equals 2 times the angle, in this case x. And when you divide by 2, you get 35 for that angle. So that is no different than if we were to have a secant and another secant, two of these things right here that look the same. So that means that this angle here is just 35 degrees. Now, if we were to have the same scenario, but we were not looking for the angle measurements or the arc measurements, if we were looking for the lengths of either that tangent or that secant, so let's say we got the secant here and we got the tangent there. If this were the case, and instead of looking for the angle measurement, if we were looking for the length of this tangent from, we'll call it A to B, if I wanted to find the length of AB, and we called that x, and we knew that this part right here was 4, and we knew that this part right here was 5. So the secant part is going to behave as if it were a secant, and you would have to deal with the outside times both of them, which the outside is 5, and both of them would be 5 and 4 put together. But on A to B, this part, we only have an outside. That's just going to be the outside times the outside because there is no both. So I did out times out, or out squared. So for the outside on the secant part, right here, this 5, we'll do 5 times 5 plus 4, which is 9. You could probably do that in your head, is equal to the outside times the outside. Well, in this case, that is x times x, which we could just write x squared. So we have 5 times 9, 5 plus 4 is 9, is equal to x squared. 5 times 9, 45, is equal to x squared. And then in order to solve that, you would need to square root. And the square root of 45 is one of 3 things. You could either leave it as the square root of 45, you could simplify the square root of 45, which is equivalent to 3 square root of 5, and that would be because the 45 is really the square root of 9 times the square root of 5, and the square root of 9 is 3. And the square root of 5 is the square root of 5. And the last thing you could do is actually find the square root of that using a calculator. And the square root of 45 as a calculator answer would be 6.7 approximately for x. So depending on how your teacher or professor prefers the answer would be which format you would have to put that. All right, so that means that this part right here from A to B is about 6.7. Next example, everybody. These problems don't get too much harder. until you have to FOIL or factor or do something crazy like that. So we're going to take another one. We're going to go with a secant here to here, and a tangent. And here I am going to make this my x. I'm going to make this a 4. I'm going to make this an 8. So we're looking for the length of that part from here to here, which is a chord. We'll call it a B for that chord. So we have to do the outside times both of them for this secant right here. But on the other side, the tangent part, we would have to do the outside times the outside, so out times out. So for the outside on the top part, we have a 4. For the both, that would be a 4 and an x, so you write that as a 4 plus x. And the outside times the outside for the other half of the equation would be 8 times 8, or 8 squared. We have to distribute the 4. You get 16 plus 4x is equal to 64. 8 times 8 is 64. Subtract 16. We end up with 4x is equal to 64 minus 16. We gotta get an 8 and then a 48. And 48 divided by 4 is 12. So that means that this part from A to B would be 12. Be careful, sometimes they don't want just A to B or just X. Maybe they want all the way from C to B, which I just added point C, and then you have to add the 4 and 12 together to get 16. So you just got to be aware of situations like that. Our last situation for today is by far the easiest. We got a circle, but instead of a secant and a tangent, we are going to have one tangent and another tangent intersecting. And these are the easiest to understand, and that is because this tangent and that tangent are guaranteed to be equal. So if this was a 3x plus 1, and the other side was a 2x plus 8, we'd be able to just set those two things equal to each other. Whatever they happen to be, we would be able to set them equal to each other. So we have 3x plus 1 equals 2x plus 8. We'd subtract the 2x. 1x plus 1 equals 8. Subtract 1. And x would equal 7. Woo! X would equal 7. Let's say I actually wanted to find out this tangent from A to B. All we'd have to do is just plug in the 7. So we could do AB is equal to whatever 2 times 7 plus 8 is. Well, that means AB would equal 14 plus 8, 2 times 7. And that means AB would equal 22. Which would also mean that the arc up here, not arc, tangent up here would also have to equal 22. And you can check that as well. 3 times 7 plus 1, well 3 times 7, 21, plus 1 is also 22. Alright? So, that is the easier version of what would happen if you have a tangent and a secant, or two tangents. Two tangents never get any more difficult. Tomorrow, we're going to be dealing with tangents and secants, but we're going to add in an extra algebra element. The geometry is still the same, but the algebra element does get a little more difficult as we move forward. So until then, stay thirsty for knowledge, and I will see you later. Bye.